Concentrate, concentrate. Okay, according to the book, the first one is should be clockwise, the second one should be center, and the third one should be CCW. The turning is like that first. On the reference to 0 degree, we will wait on the particular practical on the board later, not today. But today I want to teach you something very, very hard to understand, but you have to try to understand. Okay, how we want to generate the PWM. Alright. Let's look at the code here. Ready, eh? Okay, this code is basically using the interrupt, which is I taught you guys before 3 types of interrupt. The first one is RB0 RB0 interrupt. Second one, the changes on RB4 to RB7, and the last one is timer 0 interrupt. So this type of particular code is using timer 0 interrupt. So what is timer 0 interrupt? Timer 0 interrupt is the interrupt that use the clock from the board. Is internally triggered. Means that once you turn on your system, the system start to calculate the time. No matter what happened, it will always calculate up to particular time, and after for some time it will do the interrupt procedure. Okay, so that is the main first. So today I should cover timer 0 plus interrupt on timer 0 and the servo motor. It should be 3 things today. So you have to look carefully. If you do not understand, you have to go back to the video and look at it. Alright? So now, here is the code. So no matter what, the first function is for the interrupt function. Okay, there's no problem on that because every time you use interrupt, you must have this particular void interrupt function. So put it down first, this one. Look at the configurations of the setting here. Okay, the first one, option register. This is a new register for you to learn today. Option register is used to divide the frequency. You can open up the book at timer 0 page. Timer 0 at page 136 and 137. Open up that page first. You can mark that page, mark that page accordingly because we have to learn this one later. Dr. Zaki will teach you again the timer 0, but I'll teach you first. Okay, option register. The purpose of option register is to control or to set up the divider of the frequency, the prescaler they call it. They call it prescaler. Prescaler. The function is to divide the frequency. That is the function. So on the board, we are using 20 megahertz. That is your clock function. So this option register will divide this particular clock accordingly to your settings over here. Now the setting is option reg is equivalent to 0B 10000000. Look at page for the option reg register, page 135. Mark that one. Over there is the details on the option reg register, they call it. The option register is the readable and writable register which contains various control bits to configure the timer 0 prescaler. Okay, so look at the figure 9.3. The lower one is option rack. That is this particular register. The register is 8-bit size. So there's a bit 7 and 2 bit 0 over there. Alright? Now, the thing that you need to check is the configuration at the 3 bits lower, bit 0 to bit 2, which is the name is PS0, PS1 and PS2, which is these 3 bits. Okay, that 3 bits is basically showing to the table on page 137, figure 9.5. So the setting is accordingly to that particular table. The setting now is 0, 0, 0. So look at the table 0, 0, 0. So select that particular table. The bit value is 0, 0, 0. The timer 0 rate is 1/2. 1 to the ratio 2. Option rack 0, 0, 0. The timer 0 is setting up like this, 1/2, which means that you are going to divide the time to 2. Make it longer. Okay? That one is the setting first, So this is the function. Alright? So far okay? The function, right? So refer to that one. Next one, the command is thrice A0. Thrice A0 means you are setting up your port A to all output. This one, So port A is equivalent to FF, means that all port A will be generated 5 volts by default. But now, for port A, I told you before, the port A at the page here can be either digital or analog input. So right now you are going to use it as digital output. So you have to set it up. The register that required to do the setup is, they call it Con1 register. Con1 register is at the A to D function. Let me check first. Page 125. For Con1, look at the page 125. That is for the Con1 register. Okay, Con1 register. The purpose of this register is to set up the port A and port B either to be a digital output input or analog input accordingly. So right now the setting up is Con1 is 0x, this is in terms of hexta number. So 06 is equivalent to 0, 0, 0, 0, 0, 1, 1, 0. This is equivalent to 06. 0 times 06 in hexa, this is in binary. Just change it. Same goes to port A, equivalent to 0xFF, means all is 1, 1, 1, 1, 1, 1, 1, 1. So your port A is equivalent to all high. Okay, so far? Alright, now for the Con1. Con1 at page 1 to 5, that is the most important part for the setup of the port A and port E digital output. So you have to look at the 4 last bits. 4 last bit at R/W0, the PCFG0 to PCFG3. that is the last 4 bit. Okay, that 4 bit is for the table figure 8.6, the next page. So 1 to 5, 1 to 6. So now look at this particular setup. This is a 0, 1, 1, 0. So look at the table back on that one, the particular table figure 8.6. Look at it, this particular settings, which is 0, 1, 1, 0. So where is it? 0, 1, 1, 0 is not there, but there is 0, 1, 1, X. X in digital, it can be either one. This is the don't care situation. It can be 0, it can be 1. So you have to select that one. That one means all port A, AN7 to AN0, port A and port B all change to digital output. D means digital. So you can look at that, all AN now is digital output. Alright? Now this particular ATCON1 register is to set up your output as digital for AN0 to AN7. If you do not use this particular register, your system does not work because that particular pins do not know what is actually the states. Is it digital or analog? I do not know. So you have to make sure that you set up those things as digital first. Okay, this is the one. I repeat, this is a hexa number. Go back to this one. Check that particular things and look at the table over there. Which pins that you set as digital output. So for the case here, all is set up as D. D is for digital. Okay, so far? Alright, next. INCON. This is a register that we learned before. INCON is interrupt control register. For this particular A0, A0 means 1, 0, 1, 0, 0, 0, 0, 0. So this one is to enable the timer 0 interrupt. You can go back to the interrupt title, interrupt chapter. This particular setup is to set up the timer 0 enable. Okay, done that? This one? Now count is equivalent to 0. You start back, your count is equivalent to 0. So now, your while one, your main program starts. Remember that every time your system start, the time start to calculate already. Time start to increase, no matter what happened. Start, you will start. Okay, now what time now? Still there. Let's look at the timer 0 here. Timer 0 now page. This is a crisscross. Hip hop across the book. Timer 0. Timer 0 is at page 136. Okay, for the timer 0 interrupt, it will use the timer 0 register. Timer 0 register state over here, the size is 8-bit. Timer 0 register is 8-bit register. Okay, timer 0 register is 8-bit size. Which means that every time the system count, the highest number will be only from 0 to 255. Which is a 2 to the power 8. The maximum number for the timer 0 to calculate only up to 255. Okay? Because of this 8-bit size. Every time it calculates, every time it increases the number, there will be a time allocated here consistently, previously, accordingly to the hertz over here and the prescaler over here. So every time you start, the counter will keep on increasing from 0 to 255. What happened after 255 is, it will go back to 0. 255, go back to 0, calculate back, 255, go, this is a continuous period happens. So now this particular area, when this one 255 go to 0, this condition they call it overflow. This is not the same one like your microfeed overflow. This condition say that if I see 255 reset back to 0, means that this is overflow condition, the interrupt must happen. This is overflow, So you just imagine there's a container over here, there's a tap over here, put down the tap so the water will increase, right? Up to one level, the water will overflow. This is a considered overflow terms definition. Okay, so now what happened, when every time the 255 is go back to 0, the overflow happen, the interrupt must happen. That is happening at the back of the system. So now let's look at the program over here. Okay, right now, by default, your port A now is a digital output. Your port A now is, port A is equivalent to 0 FF, means the state is high in the beginning. Your port A, this is your port A, is high in the beginning, so it's going to move here. Up to one time you want to pull it down, and then go back here, and then you want to pull it up like this. So this is around 1 millisecond, this is around 19 milliseconds, right? So you have to know that when you have to pull it down. Go up and go down. So now look at the interrupt here. When you run your code, the timer 0 here is not stated, but it is by default is 0. So you run your program, this timer 0 will counting 0 to 255. Up to 255, you will go back to 0, interrupt must happen. So the system will go to the interrupt here. Your interrupt say what? If interrupt happen, your count is equivalent to plus plus, which means that your count now is equivalent to 1. Remember, you start from 0, Now I check my interrupt in my count. If my count is equivalent to 200, is it 200? Still 1, So this one skip, It will jump up. It doesn't care, it jump up over here. This is a statement that we learned before. Every time the interrupt happens, you have to clear back the flag. Remember that. This statement is to clear back your interrupt flag. So make sure that the next interrupt can happen correctly. So this is to clear your interrupt. So if the count is 1, then go back to the main program. Main program say what? You can see over here, main program say what? If count is equivalent to 10, is it 10? Still 1, right? Go here, nothing happened. But your counter still counting. Timer 0 still counting. Timer 0 still counting again. For 255, go back to 0, interrupt happen again. So the system will go up again, count again to 2. This one check for 200, nothing happen, right? This one go here, 2, nothing happen. So up to 10 times. What happened now? If go up for the 10th interrupt, the count is equivalent to 10. This one nothing happened yet because it's not 200. Now you go to the while one loop. If my count is equivalent to 10, my port A F0 will all pull down. So after a certain time, my port A pin 0 will be pulled down after 10 times of count. Correct, right? Correct? So after 10 times, it will pull down. So now what happened? Your count still 10. The interrupt still still happen because the timer 0 keep on continuously, never stop. It will always go up back 255 to 0, 255 to 0, up to 200. If 200 happens, now if my count is equivalent to 100, I will reset back my count to 0. Then my my port A is going to be up again. So what happened now? After 200 times over here, this is 200 times. This is 200 times of count. So my signal will go up back according to the particular interrupt statement. Should you agree? Agree, right? So 200 here is over here. So the formula is accordingly to the timer 0 formula. Page timer 0. The F clock the F out is equivalent to, this is at page, you can see that from page 141. Page 141 is equivalent to F clock divided by 4. This is your execution on the chapter 1 times prescaler times timer 0 cycle times count. Count is this one. Alright. This one, timer 0, is basically you are using 0 up to 255. So the value will be 255. The counter is 255. So now for the first 10 count, you can put here F clock is equivalent to 20 megahertz divided by 4. Prescaler means 1/2, so you have to take 2. Here just now is 1/2. Your option rate is equivalent to 1 to 2, so you divide to 2. 2 times 255 times the first 10 count. Can you calculate for me, please? What's the result? The first F out is, this is F frequency. What's the frequency? Sorry? 20,000? 20,400. Everybody got the same one? So can you get me the clock tempo? This is hertz, 1/this one. T is equivalent to 1/that one. Can you please one? You get the right one or not? Correct or not? You get the one? 20 megahertz, 20 mega, divide by 4, divide by 2, divide by 255, divide by 10. Is that correct or not? I don't think so. Let's double check. So my answer is 98039 hertz. You must get this value. Correct? You get it or not? Get it? So the tempo is 1 over this one is equivalent to 102 times to the 10 negative 3. This is 1 millisecond. Correct, right? So that is the value for the first wave on port A pin 0. So that's why you can see that the first value for pin A for F0 is equivalent to this one. This is 10 milliseconds. 1 millisecond. So now the interrupt say now after count is equivalent to 100. If the count is equivalent to 100, my count will be reset back to 0. Then my port A will be back to top to this one. So the whole 200 is over here. So instead of using count as 10 just now, so you calculate up to 200. What's the value over here? Can I get the answer? 20 megahertz divide by, open up the bracket first. You don't open up the bracket. So 20 megahertz divide, open up the brackets, 4 times 2 times 255 times 200. You can get the frequency. What's the frequency? 49 hertz. Sure not? 20 megahertz, 20 mega divide 20 megahertz. 49 megahertz. So 49 megahertz. Sorry, sir, this is how much hertz? After dividing 49 hertz. Hertz, correct. Yeah, the tempo is going to be divided by hertz. So how many hertz? 49 hertz. 1 over 49? 1 over that one? What's the value? 0.02, so 20 milliseconds. So the T is 0.02. So 1, 2, 3 is equivalent to 20 milliseconds. Can you see it? I do that. So right now, this is the interrupt keep on happening by itself because the timer 0 keep on continuously counting by itself accordingly to the clock. The clock never stops, so the timer 0 will need to counting by itself 0 to 255. So every time this 255 go back to 0, this is the terms that overflow. The timer 0 must go and interrupt. Interrupt, go up and do the interrupt and go back here. So that's why you can see that the count is at 10, at 15, at 18. As long as the count is not yet up reaching that particular number, the interrupt will still keep on continuous happen until the count go to 10 and 200. After 200, it will reset back to 0 and the period still keep on moving by itself. So you can see that your PWM is consistently like that.